So we're going to keep using the chain rule, which again is this idea of taking the derivative of inside and outside functions. So the composite functions is the correct term for it. And what we're doing is when we take the derivative of a composite function, we'll have the derivative of the outside function, keeping the inside function, times derivative of the inside function. All right, so with these, we're going to use more of this chain rule, but specifically with cases that are going to mix in the quotient and product rule. So again, I know I'm saying this in every single video, but I'm just going to keep emphasizing it. Having a piece of paper somewhere with these rules listed out will be so helpful. I remember when I was a student, my old calculus textbook, it came with a removable sheet that had every derivative formula on it. And we all immediately ripped it out of the book so that we could have it next to our homework whenever we were working. So having these rules available is going to be super helpful. All right, so if we have something like this and we're trying to determine what's the outside function and what's the inside function. So something we can notice is that at the outside of everything, we have division. So like, again, what can be helpful is think about if you plugged in something for t. So what we would do is say we're plugging in 1, that's kind of a nice one. We plugged in 1, we'd raise it to the 4th power, multiply it by 2, the minus 1. And then we would take that value and raise it to the 3rd power. So basically we would be simplifying this entire denominator before we even look at our numerator there. And this is true of fractions. Typically we're working with the numerator and denominator separately, and then once they're both simplified, then we divide. So what we're going to do is, if we think about this idea of taking the derivative of the outside, what we're going to do is use our quotient rule. In fact, I'll even write that over to the side here, quotient rule. So when we use the quotient rule, so following our rule, we go low d high. So we're going to have 2t to the 4th minus 1 cubed. So we have our denominator times the derivative of the numerator minus, and high d low, so numerator times the derivative of the denominator all over the denominator squared. Okay. All right. So I'm going to do this. So with this, I always work in 3 pieces. We have this first piece, second piece, and the denominator. So just focusing on our first piece here. So taking the derivative of 5, it's going to be really nice, is that whenever we take a derivative of a constant, that's just equal to 0. And if we multiply by 0, all of that's going to wipe out. So really this first piece here, we end up losing, or not losing really, but it all turns into a big 0. So this wipes out with that multiplication, and that's pretty nice when you're taking the derivative of a constant. So with that, we can move on to our second piece. So negative 5 times the derivative of 2t to the 4th minus 1, all in parentheses, raised to the 3rd power. And right here, we're going to need to use the chain rule, because we have this outside function raising something to the 3rd power, and this inside function doing 2t to the 4th minus 1. So what I'm going to do is I'm taking the derivative. I have this negative 5 times, and now I'm going to take the derivative using the chain rule. So first part of my derivative is seeing this outside, so raising something to the 3rd power. When we take the derivative of that, the 3 drops down to multiply with the base raised to a power of 3 minus 1, which is 2. And we're keeping that inside function, so that's staying 2 to the 4th minus 1. and then we multiply by the derivative of the inside function. So derivative of 2t to the fourth minus 1. So we're going to have a 2 times 4, which will give us an 8, t, and then 4 minus 1, which is 3. And then the derivative of negative 1 is just 0. So we end up with just 8t cubed. So just for this derivative part, we ended up with 2 pieces that came from the derivative of the outside function, keeping the inside, times derivative of the inside function. All right, and then this is all going to be over, and here we'll need to use our power rule. So we have this inside of 2t to the fourth minus 1, and then for an exponent we'll have 3 times 2, which is 6. And now we're just going to simplify down. So let's see, up here we have a negative 5 times 3 times 8. So let's see, a negative 15 times 8 is negative 120. We have this 2t to the fourth minus 1 squared over 2t to the fourth minus 1 to the sixth. So we have these common factors that can cancel out. So how you could think of this is we have 2 of them up here, 6 of them up here. So 2 can cancel out, so we're going to be left with 4 in that denominator. So we're going to keep negative 120 staying in the numerator over 2t to fourth minus 1, and our new exponent is 4 since 2 of those canceled out numerator to denominator. And that's our derivative. So at the outside of everything we had our quotient rule, but when applying the quotient rule we had the spot where we needed to use the chain rule. So these rules can layer with each other, and most often they will, so we need to get used to when do we apply what rule. All right, let's take a look at this with our product rule. So we have a function. We have x to the fourth times square root of 4x plus 1. And if it's helpful, which it is, so I'm just going to say, I'm going to start, when I see that square root, I'm going to change it to a power. So x to the fourth times, and then in parentheses, 4x plus 1 raised to a power of 1/2, instead of having this square root symbol. Okay, so we have 2 things multiplying. So when we take the derivative of 2 functions multiplying with each other, we have our, I can't remember the order, but luckily with the product rule it doesn't really matter. Let's go with, we'll have our first function times the derivative of the second function. So derivative of that 4x plus 1 raised to the 1/2 power. And then we add that with our second function, so 4x plus 1 to the 1/2 power, times the derivative of the first, x to the fourth. Okay, so let's simplify this down. We have x to the fourth times, and this derivative of 4x plus 1 to the 1/2 power, this is going to use the chain rule. So at the outside of it, we are raising something to the 1/2 power. The inside of it, we're calculating 4x plus 1. So taking the derivative of something to the 1/2 power, we're going to have the 1/2 comes down to multiply. We keep the inside, so we keep that 4x plus 1. And then for the exponent, 1/2 minus 1, which is a negative 1/2. And then we multiply that with the derivative of the inside, so derivative of 4x plus 1, which will just leave us with a 4. And then we're going to add this with 4x plus 1 to the 1/2 power times the derivative of x to the fourth, which is just our power rule, so that'll be a 4x cubed. All right, let's simplify down. So we're going to have 4 times 1/2, so that's just going to leave us with a 2. We're going to have that x to the fourth, and then in the denominator, so that negative exponent's going to move this to the denominator for a square root of 4x plus 1. And then we're adding this with 4x cubed times the square root of 4x plus 1. And in terms of simplifying, that's fantastic. There's like a common factor of 2x cubed that we could factor out from everything, but this works great right here. All right, one more. Okay, so with this one gets interesting, which interesting for me usually means it gets tricky, but we get to go through it together. Again, steps, slow and steady. You even want to pause the video and try this for yourself first. That's highly recommended. So, at the outside of everything, I'm raising everything to this 5th power. The inside, we have something that would use the quotient rule. So, with this one, when I start taking the derivative, this one I actually start with the chain rule. So this one's a good one to compare with that first example that we did in this video. So notice with this one, the outside of everything, we had numerator over denominator. So we started with the quotient rule because when we take the derivative of this, we're looking at a fraction. But with this one, at the outside of everything is something raised to a power. So when I start taking the derivative of this, I'm focusing on that exponent of 5 first. So that's why we're starting with the chain rule. So using the chain rule, we're taking exponent of 5 with those same insides, which is 2x plus 3 over 5x minus 1. And then our new exponent is 5 minus 1 times 4. So there's the derivative of the outside, keeping the inside. Times, and I'm going to write this with derivative notation. So we're multiplying by taking the derivative of that inside function, which is 2x plus 3 over 5x minus 1. Which right there needs the quotient rule. So basically, as we work through this 5 times 2x plus 3 over 5x minus 1 to the 4th power, this portion is just going to keep hanging out. Here we have work that we need to do by applying that quotient rule. And what we could do is just separate it up. That is completely fine for me, of just, let's focus on taking the derivative using the quotient rule to the side, and then we'll plug it back in and work with the other pieces. So either way, you can keep the work all together or you can separate it up. So let's look at separating it. 2x plus 3 over 5x minus 1. So we start with the quotient rule. Low d high. So 5x minus 1 times the derivative of 2x plus 3 minus high d low, 2x plus 3 times the derivative of 5x minus 1 all over low low, which is, so our denominator is 5x minus 1, and we're going to have that squared. All right, we have 5x minus 1. The derivative of 2x plus 3 is just going to be 2, and then minus 2x plus 3 times the derivative of 5x minus 1, which is just 5, over 5x minus 1 squared. All right, over here we're going to distribute the 2 in, so we're going to have 10x minus 2, and then minus, let's see, distribute the 5 in, and I'm going to keep parentheses here, so we're going to have 10x plus 15. I need those parentheses because that negative is going to distribute. So when that negative distributes, we're going to have a minus 10x and minus 15. So subtracting the 10x, those 10x values just cancel out. So we have a negative 2 minus 15, which is negative 17. And 5x minus 1 squared. Nothing's going to reduce down there, so we're going to leave it just like that. And now what I'm going to do is go back to my original spot and make the substitution that the derivative of that quotient is negative 17 over 5x minus 1 squared. So, let's see here. Derivative of 5 times 2x plus 3 over 5x minus 1 to the 4th power times negative 17 over 5x minus 1 squared. And now you can just simplify down. So I'm going to do a few things here, because it'd be nice to combine those 5x minus 1 values together in the numerator, or sorry, the denominator. We have this 5 times negative 17. So let's do 5 times negative 17, get that going. So that's a negative 85. What we can do is, with this exponent, separate it up to the numerator and denominator. So this is like a 2x plus 3 to the 4th power in the numerator over 5x minus 1 to the 4th power. And then what we're doing in the denominator is also multiplying on this 5x minus 1 squared. So in simplifying, let's see, negative 85 times 2x plus 3 to the 4th power in the numerator over, and we're going to combine those 5x minus 1 values, and we add those exponents together. So 4 plus 2 leaves us with 6, and that would be our derivative. Okay, so again, I know I mentioned this in the last chain rule video, but I filmed this before going over the derivatives of the exponential and logarithmic functions. So with the exponential functions, there are some pieces with chain rule in there. So be sure to go back and watch that if you're kind of going in that order. But this is how we can layer our different rules together.